All right, we're going to do number 5 here. Number 5. And I think we can, ladies. All right. I think we've been through before why this is the correct vector diagram. Other classes. Okay, so now what we need to do is we need to add RA to RB, find RC. Right, that's what the question is asking us to do. If it was just a right triangle, it would be just a squared plus b squared is c squared. But it's not a right triangle. So what we need to do, well, there's 2 ways to do it. You could use the ratios for a non-right triangle. We haven't talked about them. They probably, by the end of the year in pre-calc, you would know them. So I haven't talked about it because that's beyond where we're doing math. So the other way to do it is to break the values up into parts, add the parts together, and then find the new whole. All right? And I think we talked about that the other day, and I really confused everyone with how to break up numbers. Yeah. So I know we've done this one. Right? Was it not? Maybe it wasn't in this class. Maybe it was my other one. But, so what I'm going to do is I first want to take and break up the 2 vectors I want to add. I'm going to break them into their components. Because if I can find the components, the vertical and the horizontal parts of A, I can add the horizontal parts of A to the horizontal parts of B and get the horizontal parts of C, and so on and so forth. All right? So I'm going to first take vector RA, which I have pointing in this direction, and I'm going to figure out how much of it points horizontally and how much of it points vertically. And then I'm going to do the same thing over here with vector RB. I'm going to figure out how much of that points horizontally, or its horizontal component, and how much of that points vertically. All right, that's my first step. And then I'll combine the green with the green, the blue with the blue, and then combine those back up to get black again. But now I need to glean or pull some facts that they gave me. And they told me, let's see, that RA points at 20 degrees below the positive x-axis. So they told me my green is in the positive x direction. They told me this angle that connects my green to my black is 20 degrees. That's a fact from the problem. And then it has a magnitude 48 meters. So that's my length here. So that's 48 meters. That's the length of that black vector. And now I'm looking at B. Angle of 53 degrees above the positive x-axis. So that's between the green and the black here in the other triangle. For me, that's 53 degrees. And that number is different for everybody, right? So be careful there. And has a magnitude of 75 meters. So this length is 75 meters. So the length, the things that aren't in common between me and you, is 53 degrees and the 48 meters. So make sure you have down your own numbers for that, not my numbers. All right, so now I'm going to stick over on this side. I have, let's call the horizontal here, let's call that A sub x, and we'll call the horizontal on this side B sub x. So the part of B that's in the x direction, the part of A that's in the x direction. For the verticals, we're going to call this A sub y and B sub y. You could have called them Fred and Harry. Doesn't matter, right? I'm just picking those because they make me happy. And now I want to figure out the values for those. So this is where I pull out my ratios of SOHCAHTOA. And you guys saw the new improved equation sheet with SOHCAHTOA on it, right? Okay, there's copy. It's up online. There's also copies in the top file drawer if you need them. Everybody else has this problem done? Cool. Good. So now I'm going to break these into their parts. A sub x is adjacent to it, so it's cosine. So I'm going to use that cosine of 20 degrees equals adjacent, which is my A sub x, over the hypotenuse, which is 48 meters. If I rearrange that, I get 48 meters times cosine of 20 degrees equals AX. Does that make sense? Do the same thing for BX. I'm going to skip that first little math step because I think you guys see it now. And I'm going to get that BX equals 75 meters cosine 53 degrees. Right? Do you guys see how I got? Yeah? Bob, you good with that? Okay. Now, I need to do my y components. The y is related to sine, right? So I can, on the A side, I have 48 meters sine 20 degrees equals A sub y. And on the B side, I have B sub y equals 75 meters sine 53 degrees. Good? All right, see how I got those four components? Once I have these values, I'm going to say, okay, well, I'm going to take my green, AX goes in this direction. That's AX, right, for my little diagram. And BX also goes in that direction, so I add those tip to tail. Then now I need to add to those the Y dimensions, right? So AY goes down, so I draw that one tip to tail down like that. And that is A sub Y. And then tip to tail that, I write B sub Y. Remember, always arrange tip to tail. And what I want to find is my vector C here. So my vector C has components. I'm just going to redraw C again just to make it clear. So I've got C that's pointing in this direction. Its horizontal part is AX plus BX, right? Because they're in the same direction, so I just add them together. Its vertical part is B sub Y minus A sub Y. B minus A. Because A was pointing down and B was pointing up. Alright? Oh, now I have a right triangle. And let's see, let me just check something. They want, what angle do they want? They want counterclockwise from the x-axis. So the x-axis is this horizontal, right? So they want this angle in here, theta. Huh? Can I? Do you guys mind if I make up numbers for these, just so I don't have to pull out my calculator? I'm going to say this one for me is 51, and this one is 32. I did the calculations really quick in my head. That side is 51, and that one's 32. So I want to find C now. C, now, I better write this. Made up numbers. So C is I'm gonna use A squared plus B squared equals C squared. A is 51. B is 32. And I'm looking for C squared. I'm looking for C. So I'd find out, I won't be lazy on this one. I'm going to find out that 51 squared plus 32 squared is 3625 equals C squared. But I need to square root both sides and get that C is 60.2. Caitlin, yeah? Okay. Now, I need theta. Theta, I'm going to do it just over here. Theta, the sides I know the opposite side and the adjacent side, which is tangent. So tan of theta equals the opposite side, 32, over the adjacent side, 51. And this is the most advanced math I have to do, right? I got to get theta out of that function. So I do the inverse tan of both sides. I get theta equals the inverse tan of 32 over 51. And so I end up with my made up numbers. Uh, 32.1 degrees. Because they asked me for the magnitude, which is C, the length of the vector, and the direction of the vector. Right. That's kind of why I wrote them next to each other, because you could do either one, they're not dependent upon each other. And to be honest, it would be less mathematical steps if we didn't break them into components. I could do it in about 2 or 3 mathematical steps if we didn't do the component parts here. But the math is a lot more straightforward by doing the component parts. Okay? But you're right. That is... On to number 10 here. And you're walking 18 meters straight west and then 25 meters straight north. And we want to find out the displacement, because how far are you from your starting point? That's your displacement. Right? Distance would be the path you followed. What is the compass direction of the line? West of north. Now, I'm going to grab this so I don't have to redraw it. Got to get to a new page. Pasted. Now, here's the little... Yeah. Here's the little thing that they threw at you that you probably didn't see. They ask you, when they ask for the direction, that you give west of north. West of north means I point north, so I point in that y direction. They have north labeled in the y direction. And I swing west. So they're asking you, give me this angle. Theta, that's the direction they want. Well, they set up your triangle to be able to find that angle, you can only find angles that are inside your triangle, right? So we've got a choice. You know, think about all the things we know about triangles and how they go with the coordinates. We could find these angles inside here because we know, say, this one is a right angle. We know that. What does the green and the blue angle add up to? 90. So we could find that blue angle and then subtract it from 90. Or if I look, I've got two parallel lines here, and I've got alternate interior angles. So this angle up here is theta. So either I can find the blue and subtract it from 90, or find the green and have my answer without doing any more. So it's a little bit of geometry you had to think about in there. All right? I'm assuming you said the first part went well, so you did Pythagoras, right? So that was enough of an explanation? Bob, do you want me to go further through this one? Okay. Because you do Pythagoras to find r, and then I would do tan to find theta. Well, if you find the blue, you're going to subtract it from 90. If you find the green, that's going to be your angle. You ended up with 45 degrees. 35.7. Ah, okay.